From the very moment we look at the night sky, we are confronted with a paradox, a sense of grandeur intertwined with an unmistakable feeling of smallness. Our home Earth seems enormous to us, a sprawling planet with oceans, mountains, forests, deserts, and cities stretching as far as the eye can see. To a human, Earth is vast. It is our entire universe, the stage upon which every story of civilization has unfolded, every dream has been dreamt, and every tragedy has been endured. Yet, when we begin to step outside the boundaries of our immediate perception, when we extend our gaze beyond the atmosphere and into the cosmic dark, Earth transforms from a monumental home to a mere speck, almost invisible against the immensity of the solar system, the galaxy, and the universe beyond. Imagine for a moment holding a single grain of sand between your fingers. That grain, tiny, almost negligible, could represent Earth in the context of our solar system. Now consider the sun, the star that dominates our skies, around which Earth orbits faithfully every 365 days. In this analogy, the sun would be a large beach ball located roughly 26 meters away from that tiny grain of sand. Think about it. Everything we have ever known, every civilization, every nation, every moment of personal joy and sorrow, fits within a tiny speck, barely perceptible from the vast distance to the sun. This comparison is not simply poetic, it is a stark illustration of scale that highlights just how incredibly small our planet is in the context of even the solar neighborhood. As we push the limits of imagination and travel further outward, the scale becomes even more astonishing. The solar system itself is a delicate arrangement of planets, moons, comets, and asteroids orbiting a single star. Mercury, Venus, Earth, Mars, the gas giants Jupiter and Saturn, the icy giants Uranus and Neptune, all these planets are part of a harmonious dance governed by gravity. And yet, despite this grandeur, even the vast orbital paths of these worlds barely begin to capture the scale of the solar system. Beyond Neptune lies the Kuiper Belt, a region filled with icy bodies, dwarf planets like Pluto, and countless other fragments that extend tens of billions of kilometers from the Sun. If we were to map this entire system on a scale where Earth is a grain of sand, these distant icy objects would be barely distinguishable, tiny points lost in the void. Even further lies the Oort cloud, a hypothetical shell of icy bodies surrounding the solar system, reaching distances nearly a light year from the Sun. It is here, in this remote outer region, that the Sun's influence dwindles, and the faint pull of gravity is barely enough to keep the distant objects tethered. The Oort cloud is vast beyond comprehension, yet even it is a mere bubble in the cosmic ocean, a subtle ripple in the grand sea of space. At this point, our Earth, once the center of all human activity, shrinks to a dot invisible from a distance, a solitary grain lost in a storm of cosmic scale. This realization that Earth is minuscule when measured against the solar system is profoundly humbling. For millennia, humans believed that our planet was the center of existence. Ancient astronomers placed Earth at the heart of the cosmos, surrounded by celestial spheres and stars whose motion seemed to define time itself. The Copernican revolution shattered that illusion, revealing that Earth was just another planet orbiting an ordinary star in a vast galaxy. And yet, even with this knowledge, our intuition struggles. We are creatures designed to measure life in meters, kilometers, and years, and yet the universe is scaled in astronomical units, light, years, and billions of years. The gap between human experience and cosmic reality is enormous, and it is in this gap that true humility emerges. Let us consider the human experience on Earth for a moment. Every city, every building, every forest and desert, every human being who has ever lived is contained on a planet that, in cosmic terms, is infinitesimal. The Earth's diameter is about 12,742 kilometers. That's enormous to us, yet trivial in the scale of space. If the Sun were a basketball, Earth would be a pea orbiting it, and the distance between them would stretch across the length of a football field. And even the vastness of the solar system, the distance from the Sun to Neptune, about 5 billion kilometers, is nothing when compared to the distance to our nearest stellar neighbor, Proxima Centauri, over 4 light years away. 1 light year alone is approximately 9.46 trillion kilometers. The numbers themselves defy human comprehension, but the reality is clear. Earth is astonishingly small. But the story of Earth's smallness is not just a tale of distance. It is also a story of perspective. From our planet, the sun dominates the sky, the moon lights our nights, and the stars appear as fixed points of light. We feel vast under a starry sky, yet we are, in the grander scheme, insignificant. The Earth, with all its beauty and complexity, is merely a tiny stage in a theater whose size exceeds our ability to measure. Our oceans, mountains, and skies are monumental to us, but they are mere surface features on a speck that floats silently through a cosmic void filled with stars, gas, and dust. And yet, in this apparent insignificance, there is wonder. Knowing that we are small does not diminish our experience, it magnifies it. The Earth may be tiny, but it is our tiny world, unique in the observable universe for the complexity of life it harbors. Every tree, every animal, every human mind exists here. And the fact that we can recognize our smallness, that we can measure it, reflect on it, and even imagine the immense scales beyond, is a testament to the power of human consciousness. We are small, yes, but capable of understanding a universe so vast that its edges may never be known. Consider the night sky again. Each star we see is a sun, potentially with its own planets, perhaps even life. And each of those stars is light, years away, sending photons that have traveled unimaginable distances to reach our eyes. When we look up, we are peering back in time. We are witnessing events that occurred millions, even billions, of years ago. Yet our planet, spinning silently in the cosmic dark, is but one point among countless others, a fragile oasis of life drifting through the galaxy. This humbling realization is amplified when we consider how the universe continues beyond our solar system. The Milky Way alone contains over 300 billion stars, each potentially hosting its own planetary systems. Our sun is not special in any cosmic sense. It is ordinary. And Earth, orbiting this ordinary star, is not unique in location. It is simply rare in the richness of life it supports. We are small in size, small in scale, but paradoxically, we are capable of seeing the vastness that dwarfs us. We are the universe contemplating itself, and so, as we begin to understand the smallness of Earth in the cosmic context, we are faced with both humility and awe. Humility, because the planet we inhabit is almost negligible in size when compared to the solar system, the galaxy, or the universe. Awe, because despite our smallness, we have the ability to reflect, to measure, and to comprehend the grandeur of existence. The tiny blue dot we call home may be insignificant in scale, yet it is the cradle of consciousness, the birthplace of curiosity, and the stage upon which we confront the infinite. To stand on Earth, to feel its gravity beneath our feet, to watch its oceans stretch to the horizon, is to witness the home of life. To step back and imagine it as a mere grain in the vastness of space is to confront reality in its most profound form. Our smallness is not a curse, it is a perspective, a doorway to understanding the true scale of the universe. The Earth may be tiny, but it is our universe to explore, to cherish, and to comprehend. And from this tiny vantage point, we begin the journey outward into the solar system, into the galaxy, and ultimately into the boundless cosmos itself. Earth is small, almost unbelievably small. And in recognizing this, we discover the magnitude of our capacity to imagine, to explore, and to grasp the universe, not by changing its scale, but by expanding the scope of our minds to meet it. That is the first vital step in understanding the true scale of the universe, knowing how small we are and yet how extraordinary it is that we can even know it. As we leave the comforting familiarity of Earth behind, we step outward into the solar system, a vast and intricate neighborhood shaped by the sun's gravity. While Earth is our home, a tiny grain of sand in the cosmic ocean, the solar system itself is an architectural marvel on a scale that is almost impossible for the human mind to fully grasp. It is a realm where distance, time, and size operate on levels that stretch the limits of our imagination, a system whose boundaries extend far beyond what we can see, touching regions where light itself takes years to travel across. The solar system begins with the sun, a star of ordinary size by cosmic standards, yet the anchor of our existence. Its surface burns at nearly 6,000 degrees Celsius, emitting the light and warmth that make life possible on Earth. The sun is not just a distant ball of fire, it is a dynamic, living engine, a sphere of nuclear fusion converting 620 million metric tons of matter into energy every single second. From the sun emanates not just light and heat, but an invisible solar wind, a stream of charged particles that shape the magnetic environment of planets and even influence the very fabric of interplanetary medium. To look at the sun from Earth is to witness the heart of the solar system, the gravitational center that governs the motion of everything from the smallest comet to the largest gas giant. The planets, those familiar wanderers of our night sky, orbit this brilliant star in paths defined by gravity. Mercury, the closest, races around the sun in just 88 days, a scorched world of craters and extreme temperatures. Venus follows, shrouded in thick clouds of acid and heat that make it the hottest planet despite being farther from the sun. Then comes Earth, our delicate oasis, and Mars, the red planet, home to towering volcanoes and the deepest canyons in the solar system. These rocky planets, known as terrestrials, are only a fraction of the solar system's majesty. Beyond them lie the giants, Jupiter and Saturn, massive worlds composed mostly of hydrogen and helium, each with dozens of moons, swirling storms, and magnetic fields that dwarf anything on Earth. Jupiter alone is more than 300 times the mass of Earth, yet it floats in the void with grace, a colossal guardian of the inner planets. The outer reaches of the solar system hold Uranus and Neptune, the ice giants, distant and mysterious. Uranus rotates on its side, a strange axial tilt that makes its seasons unlike any other planets. Neptune, farther still, boasts supersonic winds and massive storms that rage across its blue surface. These distant giants remind us that even in our own cosmic backyard, conditions can be extreme, alien, and beautiful beyond comprehension. The planets are not isolated, they are accompanied by countless moons, from tiny irregular chunks of rock and ice to worlds that rival planets themselves in size and complexity. Europa, Enceladus, Titan, these moons may hold the keys to understanding life beyond Earth, each one an entire world of its own, orbiting its planet like satellites, in an endless cosmic dance. Beyond the planets lies the Kuiper Belt, a vast ring of icy bodies stretching from Neptune's orbit outwards to tens of billions of kilometers. Here we find dwarf planets like Pluto, once considered the ninth planet, as well as a host of other frozen worlds that silently orbit the Sun. These objects are relics of the solar system's formation, ancient remnants of the cloud of gas and dust from which the Sun and planets coalesced billions of years ago. The Kuiper Belt is a region of quiet grandeur, a frozen frontier mocking the outer edge of the familiar solar neighborhood. It reminds us that the solar system is not just a collection of planets. It is a complex, multi-layered structure shaped over eons, a dynamic system with its own history and ongoing evolution. And yet, the solar system extends even farther into the mysterious Oort cloud, a theoretical shell of icy bodies that may stretch nearly a light year from the Sun. The Oort cloud is a distant and shadowy realm, home to trillions of icy objects that occasionally get nudged inward, becoming the long, period comets we sometimes glimpse streaking across our skies. Imagine a space so vast that it would take a beam of light almost a full year to cross from one side to the other. And yet this space is still tethered to our Sun, bound by its weak gravitational pull. The Oort cloud is the outermost edge of the Sun's influence, a cosmic boundary where our star's power begins to fade and the emptiness of interstellar space takes over. The distances within the solar system are so immense that human intuition struggles to comprehend them. If we scaled the Sun down to the size of a basketball, Earth would be a tiny pea orbiting 26 meters away. Jupiter would be a grape, fruit hundreds of meters further out, and Neptune would lie more than a kilometer distant. And even beyond Neptune, the Kuiper Belt and Oort cloud would stretch across many kilometers, invisible to the naked eye, yet real, solid, and part of our cosmic neighborhood. Light itself takes 8 minutes to reach Earth from the Sun, more than an hour to reach Saturn, and several hours to reach Neptune. These are distances so vast that our everyday experience is meaningless in comparison. The solar system is not static. It is a living, dynamic entity. Comets speed inward from the Kuiper Belt and Oort cloud, sometimes gracing our skies with brilliant displays. Asteroids drift between planets, remnants of the primordial formation of the solar system, occasionally colliding with planets or moons and leaving lasting marks. Even the planets themselves are in motion, orbiting the Sun, spinning on their axes, experiencing seasons, storms, and magnetic phenomena that create auroras, radiation belts, and subtle interactions that ripple across the system. This is a system alive with motion, history, and energy. And yet, even in all this splendor, the solar system is only a small island in a vast galactic ocean. The Sun, enormous by human standards, is just one of more than 100 billion stars in the Milky Way. Its gravitational influence, while dominant locally, is tiny compared to the pull of the galaxy itself. The solar system drifts through space at over 800 kilometers per hour, orbiting the center of the Milky Way in a journey that takes 225 million years to complete. We are not fixed in space. We are passengers on a moving cosmic vessel, bound by invisible forces that stretch across tens of thousands of light years. To truly appreciate the solar system's immense structure, we must consider not only its size but its layered complexity. Each planet, moon, asteroid, and comet contributes to an intricate network of motion, energy, and matter. The Sun provides the central anchor, but the system is shaped by countless interactions, gravitational tugs, orbital resonances, collisions, and perturbations that have been playing out for billions of years. It is a delicate balance, a choreography of unimaginable precision. Yet the scale is so vast that what seems small or negligible can have profound effects over time. Even as we contemplate this structure, it becomes clear how fragile and extraordinary life on Earth is. Our planet exists in a narrow habitable zone, a region where water can remain liquid and conditions can support life. A slight change in distance from the Sun or in the gravitational influences of the giant planets could have dramatic consequences. And yet, for billions of years, the solar system has maintained this delicate equilibrium, allowing life to emerge and thrive on a tiny blue dot orbiting an ordinary star. The solar system is also a testament to time. Its current configuration is the result of billions of years of evolution, collisions, and migrations. The giant planets likely moved from their original positions, scattering smaller bodies and shaping the asteroid and Kuiper belts. Comets and asteroids carry within them the building blocks of planets, molecules that may have seeded life on Earth. In studying the solar system, we are looking not just at space, but at history written in ice, rock, and gas, recorded over incomprehensible spans of time. And so, when we consider the immense structure of the solar system, we are confronted with a paradox. On one hand, it is vast, beautiful, and complex beyond imagination. On the other hand, it is just one small system in a galaxy filled with billions more. The distances, scales, and forces at play are staggering. Yet within this enormous structure, life has found a foothold on a tiny planet, and that life us has found the ability to understand, explore, and marvel at the system we inhabit. The solar system reminds us that scale is relative. Earth, while small in comparison, is massive to us. The Kuiper belt and Oort cloud, distant and frozen, are monumental in the context of planetary science. The solar system is a microcosm of the universe itself, a layered, dynamic, and astonishingly vast structure, a testament to the forces of gravity, time, and cosmic evolution. And as we prepare to look beyond, toward the galaxy and the wider universe, it serves as both a foundation and a reminder. Even a system that seems immense by human standards is only the beginning of understanding the true scale of the cosmos. The solar system is a universe in miniature, a stage for the history of matter and energy, a laboratory where we can study the processes that govern stars, planets, and moons. And within it, our tiny Earth continues to spin, nurturing life, hosting civilizations, and offering a vantage point from which we can begin to comprehend the vastness beyond. In the solar system, we see the transition from the known to the unimaginable, from the familiar to the alien, from the fiery surface of the Sun to the icy edge of the Oort cloud. We witness the scale, beauty, and complexity of a system that is vast in every sense. It is here, in this neighborhood of planets and stars, that humanity begins to stretch its imagination, taking its first steps toward understanding the staggering universe that lies beyond. As we leave the solar system behind, venturing beyond the icy edges of the Kuiper belt and the distant, whispering reaches of the Oort cloud, we find ourselves entering a realm far larger, far more complex, and infinitely more magnificent. Our galaxy, the Milky Way. While the solar system may feel immense from a human perspective, a vast arena of planets, moons, asteroids, and comets, the galaxy stretches across unimaginable distances, a sprawling city of stars. Gas, dust, and dark matter that defies conventional human comprehension, the Milky Way is not a random scattering of stars. It is a grand spiral galaxy, elegantly structured, with a bright central bulge, graceful arms that twist outward, and a faint halo that surrounds its entirety. From Earth, when we look up at the night sky, we can see a milky band stretching across the heavens. That faint, glowing ribbon is the combined light of billions of stars, each one a sun like our own, each one potentially hosting planets and moons of its own. To our eyes, it is a delicate smear of light, beautiful and mysterious, but in reality, the Milky Way is colossal. Its diameter measures roughly 100,000 light years, and it contains more than 300 billion stars. If we tried to count them, one by one, at a rate of 1 star per second, it would take over 10,000 years to finish. And yet, even this vast collection of stars is only a fraction of the total mass, for the Milky Way also contains immense clouds of gas, vast dust lanes, and the enigmatic dark matter that holds the galaxy together. At the center of the Milky Way lies a supermassive black hole known as Sagittarius A*, a gravitational anchor with a mass equivalent to 4 million suns. It is invisible to the naked eye, yet its presence shapes the motion of stars in the galactic core. Around it swirls a dense cluster of stars, burning brightly with energy and activity, where stellar collisions and explosions occur at rates far exceeding what we experience in our quiet solar neighborhood. The galactic core is a place of extremes, where gravity bends space and time, and the laws of physics seem almost to stretch to their limits. The spiral arms of the Milky Way are where much of the galaxy's magic occurs. These arms are filled with star-forming regions, vast clouds of hydrogen gas that collapse under gravity to birth new stars. Some of these stars are massive, living short and violent lives before exploding as supernova, scattering elements across the galaxy. These explosions are not merely destructive, they are creative, seeding future generations of stars and planets with the heavy elements necessary for life. Carbon, oxygen, nitrogen elements that make up our very bodies were forged in the hearts of stars and scattered across the Milky Way by these titanic cosmic events. In this sense, the galaxy itself is a crucible of creation, a living ecosystem where matter is continually recycled and transformed. Our solar system is just one of countless neighborhoods in this vast galactic city. Earth orbits the Sun in a quiet, stable region called the Orion Arm, located roughly 27,000 light years from the galactic center. Here, the Sun and its planets move in harmony with billions of other stars, all bound by the invisible threads of gravity, all participating in the grand rotation of the galaxy. The Milky Way rotates at a staggering speed. Stars orbit the galactic center at hundreds of kilometers per second, taking hundreds of millions of years to complete a single circuit. We are moving through space at unimaginable velocities, yet from our perspective on Earth, the stars appear steady, our night sky seemingly eternal. The Milky Way is not just a collection of stars, it is a dynamic, living system. Stars are born and die, stellar nurseries shine brightly, supernova illuminate the darkness, and black holes silently consume matter. Clouds of gas drift across the spiral arms, sometimes forming new clusters of stars, sometimes dissipating into the void. Galactic collisions and interactions, while occurring over timescales far longer than human history, have shaped the Milky Way's structure and will continue to do so for billions of years. And beyond the visible matter lies dark matter, an invisible scaffolding that outweighs all the stars and gas combined, binding the galaxy together and influencing its motion in ways that challenge our understanding of physics. The Milky Way also hosts an astonishing variety of stellar systems. Some stars have massive planets orbiting them, gas giants larger than Jupiter. Others host small rocky worlds like Earth, Some stars are part of binary systems, locked in eternal orbital dances with companions. And scattered throughout the galaxy are rogue planets, untethered by any star, wandering alone in the dark. Each star, each planet, each moon is a story in itself, a world with potential mysteries waiting to be discovered. The sheer diversity of the Milky Way is overwhelming, a reminder that even within a single galaxy, the possibilities of existence are practically infinite. Beyond the stars, the galaxy is filled with nebulae, luminous clouds of gas and dust illuminated by nearby stars. Some nebulae are nurseries, forming new generations of stars. Others are remnants of dying stars, glowing with the energy of past explosions. The Orion Nebula, the Eagle Nebula, the Crab Nebula, these celestial structures are not just beautiful, they are evidence of the ongoing processes that shape the galaxy, of the cycles of birth, death, and rebirth that define the cosmos. And yet, even with all its stars, planets, black holes, and nebulae, the Milky Way is just one galaxy among billions in the universe. Our nearest neighbor, the Andromeda Galaxy, lies 5 million light years away, a colossal spiral similar in size to our own. It is on a collision course with the Milky Way, and in about 4 billion years, the two galaxies will merge, forming a new massive galaxy that will stretch across the night sky. But even before this eventual collision, the Milky Way stands as a monument to scale, beauty, and complexity, a system so vast that it dwarfs anything in human experience. To truly grasp the Milky Way's scale, one must also consider its thickness. While it stretches 100,000 light years across, its disk is only about 1,000 light years thick. This thin, sprawling shape gives it the appearance of a flattened spiral, a cosmic pinwheel rotating gracefully through space. Stars, gas, and dust orbit the galactic center in a delicate balance, moving in predictable paths, yet influenced by unseen forces. The galaxy is in motion, alive in ways that are imperceptible on human timescales, but undeniable when viewed through the lens of astronomy. The Milky Way is also home to countless star clusters, from tightly bound globular clusters containing hundreds of thousands of stars, to open clusters with younger, more dispersed stars. These clusters are remnants of the galaxy's formation, fossilized snapshots of the processes that built the Milky Way over billions of years. By studying them, astronomers can unravel the history of the galaxy, understanding how stars, planets, and even life itself may have originated within it. And yet, for all its majesty, the Milky Way is only a fraction of what exists. Beyond its glittering stars lies the vast emptiness of intergalactic space, punctuated by other galaxies, each with their own stars, planets, and stories. The Milky Way is enormous, yes, but it is a single island in a cosmic ocean of unimaginable scale. Even the concept of billions of stars is difficult to comprehend, yet it is a reality that surrounds us, shaping the very space in which our tiny solar system drifts. In contemplating the Milky Way, we are forced to confront both our smallness and our uniqueness. We are insignificant in size compared to the galaxy, yet our awareness allows us to recognize its immensity. The Earth, orbiting an ordinary star in one spiral arm, is tiny, fragile, and brief in cosmic time, yet it is here that life has emerged, consciousness has arisen, and the universe can reflect upon itself. Our perspective, limited though it is, allows us to see the Milky Way not just as a collection of stars, but as a story of creation, evolution, and cosmic beauty. The Milky Way also teaches us humility. When we imagine the countless stars, the spiraling arms, the glowing nebulae, and the invisible forces holding it together, we begin to understand the scale of the universe we inhabit. The solar system, vast though it may be, is merely a neighborhood. The Milky Way, with all its complexity and history, is a city of unimaginable proportions. And yet, within this city, we exist, aware of our presence, capable of observing, measuring, and even imagining what lies beyond. And so, as we move outward from our solar system to the galaxy at large, we witness the transition from the familiar to the magnificent. The Milky Way is a reminder of scale, beauty, and the profound complexity of the universe. It is a home not just for stars, planets, and dust, but for ideas, discoveries, and the human capacity to comprehend a reality far larger than ourselves. By understanding the Milky Way, we take our first steps into the broader universe, learning not only where we are but also how extraordinary it is that we can even understand the scale of our cosmic home. The Milky Way, with its hundreds of billions of stars, its swirling spiral arms, its black holes, nebulae, and star clusters, stands as a testament to the grandeur of existence. And as we look beyond it, toward other galaxies, clusters, and superclusters, we are reminded that even this immense structure is just one piece of a universe far vaster than we can imagine. Within this vastness, Earth spins quietly, our tiny blue oasis, a fragile cradle of life and consciousness, orbiting an ordinary star in a galaxy of unimaginable scale. To gaze at the Milky Way is to glimpse infinity. It is to confront the profound realization that we are small, yet capable of awareness, discovery, and wonder. It is to see the universe reflected in ourselves, for in understanding the Milky Way, we also understand our place in the cosmos, the extraordinary privilege of being alive, and the boundless possibilities that lie beyond. As we step beyond the Milky Way, leaving behind the familiar spiral arms, glittering stars, and the quiet neighborhoods of our solar system, we enter a realm that dwarfs even the grandeur of our galaxy. The universe is not a random scattering of galaxies. It is an intricately connected cosmic tapestry, a web of matter stretching across unimaginable distances, where galaxies cluster together, forming neighborhoods, cities, and vast superstructures. To comprehend this scale is to confront a reality far larger than anything Earth-bound humans can naturally imagine. The Milky Way is itself part of a small local collection of galaxies known as the local group. This neighborhood contains over 50 galaxies of various shapes and sizes, from tiny dwarf galaxies to our large companions like the Andromeda Galaxy and the Triangulum Galaxy. Andromeda, slightly larger than the Milky Way, is on a collision course with us, a slow-motion dance that will culminate in a titanic merger billions of years from now. Within the local group, galaxies interact gravitationally, tugging at one another, influencing each other's shapes, and occasionally colliding. These interactions are not rare. They are a fundamental part of the cosmic story, shaping galaxies, triggering bursts of star formation, and even creating new galaxies from the remnants of old ones. Beyond our local group lies the Virgo supercluster, a massive collection of galaxy clusters spanning over 110 million light years. Within this supercluster, hundreds of thousands of galaxies are bound together by gravity, forming vast cosmic neighborhoods that stretch far beyond what we can observe with the naked eye. The local group itself is just one small member, orbiting within this larger structure, much like a suburban community on the edge of a sprawling metropolitan city. The Virgo supercluster is both a city and a highway system, connecting galaxies across immense distances, all subtly influenced by the gravitational scaffolding that holds them together. Within clusters and superclusters, galaxies are not evenly distributed. They are connected by long filaments of dark matter and gas, forming what scientists call the cosmic web. Imagine a network of interlocking threads stretching across hundreds of millions of light years, where galaxies are beads strung along these filaments, and immense voids of nearly empty space lie between. These voids are vast, sometimes hundreds of millions of light years across, nearly devoid of matter, creating a stark contrast to the dense regions of clustered galaxies. The cosmic web is the skeleton of the universe, invisible yet undeniably present, shaping the motion, formation, and evolution of galaxies across the cosmos. Galaxy clusters themselves are staggering in scale. A single cluster can contain thousands of galaxies, each with hundreds of billions of stars. Within these clusters, galaxies interact constantly, their gravitational pull distorting shapes, triggering bursts of star formation, and even stripping gas and dust from neighboring galaxies. The energy released in these interactions is immense, creating shock waves, heating intergalactic gas to tens of millions of degrees, and generating phenomena observable across billions of light years. In some cases, clusters collide with each other in a slow-motion cosmic dance, producing gravitational ripples that echo through the universe. The study of galaxy clusters and superclusters has revealed the presence of an enigmatic substance, dark matter. This invisible matter outweighs all the stars, gas, and dust combined, yet it does not emit or absorb light. Its presence is inferred through gravitational effects, holding clusters together and influencing the motion of galaxies within them. Without dark matter, galaxies would fly apart, and the grand cosmic web would unravel. The discovery of dark matter has profoundly reshaped our understanding of the universe, revealing that much of what exists is unseen, operating silently behind the scenes, yet exerting influence across unimaginable distances. Clusters and superclusters are also cosmic laboratories, offering insights into the evolution of galaxies over billions of years. Observations of distant clusters allow us to look back in time, seeing galaxies as they were when the universe was young. Some clusters contain galaxies that have already exhausted their gas, appearing red and dormant, while others are bursting with star formation, blue and luminous with the birth of new stars. These differences reveal the life cycles of galaxies, the influence of environment on their growth, and the interplay between matter, energy, and gravity on scales that dwarf our solar system. The scale of superclusters is almost impossible to grasp. The Laniakea supercluster, for instance, which contains the Virgo supercluster, stretches over 500 million light years and contains the mass of more than 100 million billion suns. It is a cosmic metropolis, with galaxies moving under the gravitational pull of the Great Attractor, a mysterious region that draws galaxies, including our own, toward it. Laniakea is a reminder that even our local group, vast though it may feel, is merely a tiny neighborhood within a massive network of cosmic structures, stretching far beyond human comprehension. These structures also challenge our intuition about distance, scale, and time. A single light year, the distance light travels in a year, is already almost 10 trillion kilometers. Multiply that by millions or billions, and the distances between clusters, superclusters, and filaments become truly staggering. Light from even the nearest galaxy cluster outside our local group takes millions of years to reach us. The galaxies we see are snapshots of the past, ancient images traveling across vast cosmic highways, allowing us to peer back in time and witness the universe as it was billions of years ago. The cosmic web is not static. Galaxies flow along filaments, moving toward massive clusters under the influence of gravity. Collisions and mergers are ongoing, shaping the evolution of galaxies and clusters over billions of years. In this sense, the universe is alive with motion, a dynamic structure of interconnected neighborhoods where the smallest galaxy is influenced by the gravitational pull of a cluster millions of light years away. The scale of this motion is so vast that it transcends human understanding, yet it is governed by the same fundamental laws of physics that operate here on Earth. Considering the larger cosmic neighborhood also forces us to reflect on perspective. From Earth, the night sky appears scattered with stars, and galaxies seem faint and distant. But in reality, we are part of a vast interconnected system, a small corner of a sprawling metropolis of galaxies and clusters. Each galaxy contains billions of stars, each cluster contains thousands of galaxies, and each supercluster is a network of clusters interconnected by filaments. The complexity is mind-boggling, the scale unfathomable, and yet our minds, uniquely conscious and curious, are capable of conceiving it, measuring it, and understanding it to some degree. The study of clusters and superclusters also underscores the profound mystery of our universe. Dark matter, dark energy, and the vast empty voids that separate clusters hint at realities beyond our perception. Dark energy in particular appears to be driving the accelerated expansion of the universe, stretching the cosmic web and pushing galaxies apart at ever-increasing speeds. As we look outward, we realize that even these immense structures are not permanent. The universe is evolving, expanding, and changing in ways that exceed even the wildest human imagination. Ultimately, the larger cosmic neighborhood clusters, superclusters, and the cosmic web reminds us of both our smallness and our privilege. We are insignificant in scale, tiny occupants of a galaxy in a cluster within a supercluster, and yet we possess the unique ability to perceive, to study, and to understand the universe around us. We are not just observers, we are participants in a cosmic story capable of tracing the motion of galaxies, understanding the influence of invisible matter, and contemplating the forces that shape the universe. By contemplating this vast network, we are forced to expand our concept of home. Earth is our cradle, the solar system our neighborhood, the Milky Way our city, and clusters and superclusters our cosmic continent. But even this continent is only a tiny part of the greater cosmic landscape, a landscape that stretches across billions of light years and is filled with complexity, beauty, and profound mystery. In witnessing the interconnectedness of galaxies, the grandeur of clusters, and the vastness of superclusters, we are reminded that scale is relative. What seems large to us, a galaxy, a cluster, may be tiny in the cosmic context. And yet, within our tiny corner of the universe, we have the capacity to understand, to explore, and to marvel at these structures, to trace their history, and to imagine the forces shaping the cosmos on scales that defy comprehension. The larger cosmic neighborhood is a universe of order and chaos, of gravity and motion, of light and darkness. Clusters collide, galaxies interact, stars are born and die, and filaments of matter stretch across hundreds of millions of light years. It is a dynamic, evolving, and breathtakingly beautiful structure, a testament to the forces that have shaped the universe for billions of years. And in all of this, Earth spins quietly in its orbit around the Sun, one small world in a galaxy within a cluster in a supercluster, a tiny point of consciousness capable of contemplating the enormity of existence. As we continue our journey beyond clusters and superclusters, we approach a scale that is almost unimaginable, the vast, interconnected expanse of the universe itself. The cosmic web stretches across billions of light years, linking galaxies, clusters, and superclusters into a coherent structure that defines the very architecture of the cosmos. To comprehend this, even partially, is to confront a reality far beyond human scale, a reality that dwarfs our solar system, our galaxy, and even the largest clusters of galaxies. The larger cosmic neighborhood teaches us humility, awe, and wonder. It reminds us that we are small, fragile, and fleeting, yet capable of perceiving, measuring, and understanding the vastness that surrounds us. By studying clusters and superclusters, we glimpse the grandeur of the universe, the forces that shape it, and the incredible interconnectedness of all things. We see a cosmos that is not random but structured, not static but dynamic, and filled with mysteries waiting to be explored. In the end, clusters and superclusters reveal a universe of staggering scale, a cosmic network that stretches beyond imagination, yet one that we can begin to understand. They show us that Earth is not the center, nor is our galaxy unique. We are part of a vast, interconnected structure, a network of stars and galaxies moving under the influence of gravity, dark matter, and dark energy. And in this realization, we find both our smallness and our greatness, the smallness of our physical presence, and the greatness of our consciousness, capable of grasping the enormity of the universe. As we move beyond clusters and superclusters, beyond the tangled web of galaxies that stretch across hundreds of millions of light years, we begin to confront the true enormity of the cosmos. Observable universe. This is not just our galaxy or even our supercluster, it is the vast bubble of reality that we, from our tiny vantage point on Earth, are capable of observing. The observable universe stretches approximately 93 billion light years in diameter, a distance so immense that it challenges every human instinct, defies our imagination, and dwarfs every measure of scale we encounter in daily life. To comprehend the observable universe, we must first understand what it means to observe. Light travels at a finite speed, roughly 300 kilometers per second. This means that when we look at a distant star or galaxy, we are not seeing it as it is now. We are seeing it as it was when the light left it, sometimes millions or even billions of years ago. In effect, looking outward is looking back in time. When we observe the edge of the observable universe, we are witnessing light that began its journey nearly 13.8 billion years ago, shortly after the Big Bang itself. What we see at the outer reaches is the universe in its infancy, a glowing haze known as the cosmic microwave background, the afterglow of creation, a faint whisper from the moment everything began. Within this enormous sphere, the observable universe contains an estimated 2 trillion galaxies, each a city of billions of stars, planets, and moons. Imagine the Milky Way with its 300 billion stars multiplied by 2 trillion, an almost incomprehensible number. And each of these galaxies is not static. Stars are born and die, gas and dust swirl in nebulae, black holes consume matter, and galaxies collide and merge in an ongoing cosmic dance. Across the observable universe, processes that take place over billions of years unfold constantly, yet we are capable of witnessing them, capturing snapshots of their existence with our telescopes and instruments. The distances involved are staggering. Even the closest galaxy clusters are millions of light years away, meaning their light began its journey long before humans evolved on Earth. And as we peer deeper into space, we encounter galaxies billions of light years distant, whose light has traveled across almost the entire history of the cosmos to reach us. To imagine the scale, consider this. If we could travel at the speed of light, which, according to physics, we cannot, reaching the nearest large galaxy outside the local group, would take millions of years. Reaching the farthest galaxies we can detect would take tens of billions of years. Yet, despite this incomprehensible distance, the light has arrived, allowing us to witness the universe in its unimaginable vastness. The observable universe is a bubble defined not by edges in space, but by the limits of light travel. Beyond this boundary, the universe may continue infinitely, stretching far beyond what we can detect. We do not know whether it curves back upon itself or extends endlessly. It may contain galaxies and structures as vast as what we observe, or regions with laws of physics that are entirely different from our own. The observable universe is a window into the cosmos, a sphere within which light has had time to reach us since the Big Bang. Outside of it lies an uncharted expanse, a region forever beyond our current perception, perhaps infinite in scale. Within this observable bubble, galaxies are not evenly distributed. They form vast structures, clusters, superclusters, and filaments separated by enormous voids of seemingly empty space. Some voids are hundreds of millions of light years across, regions where only a handful of galaxies exist, creating a stark contrast with dense clusters where galaxies crowd together by thousands. The universe, when viewed on this scale, is not uniform. It is a cosmic tapestry, a vast network of matter woven across unimaginable distances. The patterns of galaxies and voids resemble a cosmic web, a structure shaped by gravity, dark matter, and the energy released in the aftermath of the Big Bang. Even individual galaxies within the observable universe are extraordinary. Some are massive, containing trillions of stars and stretching millions of light years across. Others are small, irregular, and barely detectable. Some are young and blue, forming stars at incredible rates. Others are old, red, and largely dormant. And yet all are bound together within the gravitational framework of clusters, superclusters, and the cosmic web, interacting, colliding, and evolving across billions of years. The observable universe also allows us to glimpse the history of cosmic expansion. When we look at distant galaxies, we are observing a universe that was much smaller, denser, and hotter in its early stages. The farther we look, the younger the universe appears. This is because the light from distant galaxies has traveled across billions of years of expansion. Over that time, space itself has stretched, carrying galaxies along with it, making the distances between them greater than when the light first departed. In this sense, the observable universe is not a static map, but a dynamic record of cosmic evolution, a snapshot of the universe's history captured in light. The sheer numbers are staggering. 2 trillion galaxies, each with hundreds of billions of stars, means that there are more stars in the observable universe than grains of sand on all the beaches of Earth. Each star has the potential for planetary systems, and within these countless worlds, conditions for life may exist. Some planets orbit ordinary stars like the Sun, others orbit exotic stellar remnants like neutron stars or pulsars. Some may be inhospitable, frozen worlds drifting alone in the void. Others may harbor life, intelligence, or civilizations far beyond our comprehension. The observable universe is, in this sense, a library of possibilities, a vast expanse of untold stories written in light and matter. Yet, despite its immensity, the observable universe is only a fraction of the whole. The universe itself may extend far beyond what we can detect, stretching infinitely in all directions. The boundary we see is defined by the limit of light travel. The distance light has traveled since the universe became transparent approximately 380 years after the Big Bang. Beyond this we cannot observe. There may be galaxies, clusters, and structures extending far beyond, but their light will never reach us. This realization is humbling. Even as we peer to the farthest reaches of space, we are still confined to a bubble of perception, unable to see the full scope of what exists. The observable universe is also a place of extremes. We detect supermassive black holes, some billions of times the mass of the Sun, lying at the centers of galaxies. We observe quasars, incredibly luminous objects powered by matter falling into these black holes, shining across billions of light years. We see gamma ray bursts, the catastrophic death of massive stars, releasing more energy in seconds than our Sun will emit in its entire lifetime. And we witness cosmic microwave background radiation, the faint afterglow of the Big Bang, a whisper from the birth of space and time itself. Within this immense sphere, phenomena occur on scales and energies that are almost impossible to imagine, far beyond anything experienced on Earth. To contemplate the observable universe is to confront the limits of human imagination. Numbers like billions, trillions, and billions of light years are abstract, yet they describe reality. Every galaxy, star, and planet exists within this vast expanse, following the rules of physics, shaped by gravity, dark matter, and dark energy. Yet our understanding, though profound, is still limited. The universe is far larger than what we can see, and perhaps far stranger than we can imagine. And yet, in all this immensity, there is a profound sense of connection. Earth, our tiny blue dot, exists within the observable universe, a world orbiting a star in a galaxy that is just one among 2 trillion. Our planet is a witness to cosmic history, capable of observing galaxies billions of light years away, capturing photons that traveled across almost the entire history of the universe. We are not only observers, we are participants, conscious beings capable of contemplating the scale of reality, measuring it, and appreciating its grandeur. The observable universe also challenges our perception of time and space. A galaxy 10 billion light years away is seen as it was 10 billion years ago. We are seeing the past, a universe much younger than our own. The farther we look, the younger the universe appears. In this way, the observable universe is not just a spatial boundary, but a temporal one, a record of cosmic history, a story of creation and evolution, stretching from the first moments after the Big Bang to the present. Ultimately, the observable universe is a reminder of both our smallness and our capacity. We are minuscule in scale, tiny occupants of a planet in a galaxy within a cluster, yet our minds can comprehend structures spanning billions of light years. We can trace the motion of galaxies, measure cosmic expansion, detect the faint glow of the early universe, and imagine what lies beyond. The observable universe, vast and magnificent, teaches us humility, awe, and wonder. It reminds us that Earth, our solar system, and even our galaxy are mere points within an immense cosmic ocean. And yet, it also reminds us that consciousness, curiosity, and the capacity for understanding are equally extraordinary. We are small, yes, but we are the universe contemplating itself. The observable universe, 93 billion light years across, is a window into the infinite, a vast record of cosmic history, and a stage upon which unimaginable numbers of galaxies, stars, and planets play out their stories. It is a testament to the grandeur of existence, the power of physical laws, and the boundless possibilities of the cosmos. And within it, Earth spins quietly, our tiny oasis of life, capable of seeing, measuring, and appreciating the vastness that surrounds us. To look at the observable universe is to gaze upon infinity, to confront the enormity of space and time, and to recognize the extraordinary fact that we are aware, capable of understanding, and able to marvel at the universe that stretches across 93 billion light years, a scale that almost defies human comprehension. yet one that we can perceive, imagine, and celebrate. As we stand at the edge of what we can observe, the 93 billion light-year sphere of the observable universe, we are confronted with a profound question: what lies beyond? The observable universe is vast beyond comprehension, yet it is not necessarily the entirety of reality. It is merely the portion of the cosmos from which light has had time to reach us since the Big Bang. Beyond this boundary lies the unobservable universe, a domain that may stretch infinitely in all directions, a boundless expanse that challenges every notion of scale, space, and even time itself. The concept of an infinite universe is both exhilarating and humbling. It suggests that the cosmos may have no edges, no boundaries, and no limits, extending forever beyond what we can perceive. If this is true, then the galaxies, clusters, and superclusters we can see are just a small sampling of a far larger cosmic tapestry. In such a universe, there would be an endless number of galaxies, each with billions of stars, and each star potentially hosting countless planets. Beyond the observable horizon, the possibilities multiply without limit, and the universe becomes truly incomprehensible in scale. Even within the observable universe, we see hints of this vastness. Light from the farthest galaxies has traveled billions of years to reach us, yet those galaxies are only the tip of a cosmic iceberg. Beyond them, there are galaxies whose light has not yet had time to arrive. Beyond them, there are regions that may never be visible to us, because the universe is expanding faster than light can travel across it. In this sense, the observable universe is a bubble within a larger whole, a finite island within an ocean that may have no end. The notion of an infinite universe also raises profound philosophical and scientific questions. If the universe is infinite, then every possible configuration of matter must occur somewhere. Somewhere out there, there may exist worlds similar to our own, stars identical to our sun, and perhaps even versions of Earth with versions of ourselves. In an infinite universe, the possibilities are limitless, and the very concept of uniqueness becomes relative. The stars we see at night, the galaxies we observe through powerful telescopes, are fragments of an unimaginably vast reality, a reality that may extend forever without repetition or pattern, or perhaps with patterns repeating in ways we cannot yet comprehend. Modern cosmology provides intriguing evidence that the universe could indeed be infinite. Observations of the cosmic microwave background, the faint afterglow of the Big Bang, suggest that the universe is remarkably uniform and flat on the largest scales. This flatness implies that, beyond the observable region, space could continue indefinitely. Inflationary theory, a cornerstone of modern cosmology, posits that the universe underwent an exponential expansion in its first fractions of a second, stretching space itself to potentially infinite proportions. While these ideas remain theoretical, they are grounded in evidence and provide a framework for imagining a universe without bounds. An infinite universe also challenges our understanding of time. If the cosmos extends without end in space, then what does that imply about the unfolding of events across time? Are there infinite iterations of cosmic history occurring simultaneously? Could there be regions of the universe where entirely different physical laws prevail, or where matter and energy have organized themselves in ways we cannot imagine? Infinity stretches beyond our imagination, not just spatially, but temporally, suggesting that the universe is a stage for phenomena beyond the limits of human experience. To grasp the idea of an infinite universe, it helps to think in terms of scale and repetition. Within the observable universe, there are more stars than grains of sand on every beach on Earth. If the universe is infinite, the number of stars, planets, and galaxies is not just vast, it is literally endless. Somewhere far beyond the limits of observation, galaxies like our Milky Way may be repeated. Planets like Earth, with conditions conducive to life, may exist countless times. Perhaps there are regions of the universe where events similar to human history are unfolding independently, echoing the lives and experiences we know, yet infinitely removed from us in distance. Isolation. Infinity also offers a humbling perspective on human significance. On the one hand, the sheer scale of an infinite universe can make our existence feel insignificant. Earth is tiny, our solar system a mere dot, and our galaxy a single point within a cluster, supercluster, and ultimately an infinite cosmos. On the other hand, our ability to perceive, to comprehend, and to reflect upon this enormity is extraordinary. We are conscious observers within an infinite expanse, capable of imagining scales beyond our own, capable of measuring light, years, mapping galaxies, and pondering realities that stretch endlessly into the void. The possibility of an infinite universe also reshapes our understanding of space and motion. Galaxies are not just moving within clusters, they are receding from each other as the universe expands. Space itself is stretching, carrying galaxies along with it, and in an infinite universe, this expansion has no boundary. There is no edge, no center, no limit, only continuous space, expanding, evolving, and giving rise to structures across scales beyond comprehension. The universe, in this view, is an eternal canvas, and each galaxy, each star, and each planet is a brushstroke in a cosmic masterpiece without end. Scientific exploration of the infinite universe is necessarily limited to the observable portion, yet even within this limited sphere, the evidence points toward a reality that may be vastly larger. Cosmic background radiation, the distribution of galaxies, and the uniformity of space all suggest that the patterns we observe locally are likely repeated on scales far beyond our ability to detect. And while we cannot see the unobservable regions, mathematical models allow us to extrapolate, to imagine, and to theorize about a universe without spatial limits. The concept of an infinite universe also invites profound philosophical reflection. If the universe is infinite, what does it mean for our understanding of existence? Are there infinite possibilities for life, intelligence, and cosmic structures? Does the notion of infinity diminish our significance, or does it elevate the wonder of being a conscious observer capable of contemplating infinity itself? In a universe without bounds, our perspective is both infinitesimally small and uniquely precious. We exist at a singular moment in space and time, yet we can perceive the cosmos across billions of light years, across billions of years, and perhaps even beyond the horizon of what can ever be seen. Infinity also transforms the way we think about beginnings and endings. While the observable universe has a finite age approximately 13.8 billion years, the unobservable universe could extend infinitely in space and perhaps in time. Cosmic events that occur in regions far beyond our perception may continue indefinitely. Galaxies may form, collide, and evolve endlessly. Stars may burn, explode, and seed new generations of planets. The universe, in this scenario, is not just vast, it is eternal in its potential, a cosmic stage without end. Yet, despite the enormity and abstraction of infinity, it is not merely an intellectual exercise. Considering an infinite universe reshapes our sense of place and possibility. Earth is small, yet precious. Humanity is brief, yet capable of understanding cosmic scales. The universe may be infinite, yet our curiosity, imagination, and consciousness allow us to perceive a fraction of it, to marvel at its grandeur, and to seek knowledge that transcends our immediate existence. Infinity becomes not a source of despair, but of awe, a reminder of the vast canvas on which our existence is set, and the boundless mysteries that await discovery. In contemplating an infinite universe, we confront the ultimate paradox: we are both insignificant and extraordinary. Insignificant in scale, a tiny world within an unending expanse; extraordinary in perception, capable of reflecting on infinity itself. The universe may extend endlessly, yet we can measure, imagine, and comprehend aspects of it, connecting the dots of light, matter, and energy across unimaginable distances. Our consciousness allows us to witness the infinite without being lost in it, to understand our smallness while appreciating the majesty of existence. Finally, the possibility of an infinite universe challenges our imagination, creativity, and scientific curiosity. It suggests that there are always new horizons, new galaxies, new phenomena to explore. The cosmos may have no limit, but our journey of discovery is only beginning. From Earth through the solar system, across the Milky Way, beyond clusters and superclusters, to the edge of the observable universe and into the infinite unknown, the universe beckons us to look, to wonder, and to seek understanding. The infinite universe reminds us that the cosmos is far larger, far stranger, and far more magnificent than anything we can directly observe. It teaches humility, inspiring awe, and a sense of connection to a reality that stretches endlessly in all directions. Within this infinite expanse, Earth remains a tiny oasis of life and consciousness, yet it is also a point from which the universe can reflect upon itself. We are observers in the infinite, capable of contemplating scales beyond imagination, marveling at the boundless possibilities, and appreciating the extraordinary fact of our existence. In the end, the possibility of an infinite universe is a testament to the grandeur, mystery, and wonder of all that exists. It stretches our minds, challenges our understanding, and expands our sense of what is possible. It invites us to explore, to discover, and to reflect on our place in an unending cosmic landscape. And as we do so, we realize that while the universe may be infinite, our capacity for wonder and understanding is, in its own way, limitless.